This is Good Morning Scotland with Gary Robertson and FionaStalker. Good to have you with us this morning. So the energy crisis rumbles on. All manner of explanations have been offered for the dramatic surge in power prices. It's been put down to the post-pandemic economic recovery, to Europe's reliance on Russian gas. But could the answer be blowing, or maybe I should say not blowing, in the wind? Paul Williams is Professor of Atmospheric Science at the University of Reading. Good morning, Professor.
Good morning.
What part does wind have to play in this? Just explain it to us, please.
Yes, well, I don't know whether people have noticed this in their everyday lives, but it really hasn't been very windy recently. I've been looking at the data, and just to give you an example, the winds in Scotland this July were only about half as strong as we would normally expect for a Scottish summer, so about 50% slower. And it's not just Scotland, actually, it's not just July. In fact, across large parts of Europe, the entire year so far, from January to September, has been up to 15% less windy than normal. So there definitely seems to be something interesting going on here.
And what's the impact of this on our energy mix?
Well, it's a good question because we tend to call this global stilling. So it's a named phenomenon, and it does have consequences, especially for wind power generation. And that's because the amount of energy stored in the wind depends very strongly on how quickly it's blowing. And that's a very non-linear relationship. So to give you an example, every 1% drop in wind speed actually comes with a 3% drop in the energy. So it's a very steep sort of response curve. So this is not very good news for wind farm operators and indeed for all of us now, because we're all increasingly reliant on wind power to meet our electricity requirements.
And there's the suggestion, I believe, that this so-called global stilling, as you said, might not just be a blip.
Yes, it does seem to be part of a long-term trend. People have been measuring the wind all around the world for the past few decades, and we know from those measurements that global wind speeds today are about 1 mile an hour slower than they were about 30 years ago. So it seems to be a slow, gradual change, but a systematic change, and we do expect this trend to continue. The United Nations Intergovernmental Panel on Climate Change, the IPCC, has projected that wind speeds will drop by up to 10% in the summer months by the end of this century across large parts of Europe. So what's global stilling a consequence of then? Well, we don't know the full answer yet. I think it's still being explored, but there are various theories. One of them is that it's something we call surface roughness. Every time we build something, anything sticking up above the ground tends to act as a barrier to the wind and to slow it down. So it could be increasing development, the more buildings we're putting up. Another, I think, more likely explanation is climate change, and I can sense listeners' eyes rolling. We blame everything on climate change now, don't we? But there is good reason to here, actually. You can't warm the planet as much as we have without there being lots of consequences, and we know that in particular the Arctic Circle region has been warming a lot more rapidly than the rest of the planet, and that's been reducing the temperature difference between the warm tropics and the cold poles, and that's actually what drives the winds. So this is why it's entirely consistent that we would see a drop-off in the wind speeds as a consequence of the temperature changes. Just finally, and briefly if you don't mind, how's this going to alter the economics of wind power then? Well, that's very interesting. I'm not an economist, but I do know that we normally get around 20 to 25% of our electricity from wind. But just a few weeks ago, it was only 2.5% because the winds ground to a halt, and we had to switch on some coal-powered fire stations just to compensate for the lack of energy. I don't really know what this means, but I do think we have to be very careful that we're not left with an energy gap in the future when the wind stops blowing again, as it surely will. OK, thank you for your expertise. That's Paul Williams, Professor of Atmospheric Science at the University of Reading.
The time is 8 minutes to 8.